This video is an extension of the basic Tam counting video. If you have not watched that video, do so before continuing with this one. The link is listed below. When Tam counting 16th notes, downbeats and upbeats remain tas, and the notes in between are labeled T. This keeps the 8th note subdivision structure of tamming consistent. Here is an example of 8th notes transitioning into 16th notes. Ta 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 tati 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 tati. Tamming beats that include typical combinations of both 8th and 16th notes is simple as well. Ta tati ta tati tati ta tati ta tati tati ta tati tati ta ta. There are 3 other ways that 16th notes can be a part of a beat in simple meter. The concept here is the same as tamming rhythms longer than 8th notes. Start each note with a T, which represents the initial articulation, then include the ahs or e's of the notes contained within the note. This sounds far more confusing than it is. Let's take a look. Starting with tati tati as the basis. The dotted 8th note contains 3 16th notes. So we tam the T articulation, followed by the 3 vowels, ah, e, ah, and then the last 16th note is separate, so it remains T. This rhythm is tammed ta-yati. Similarly, this rhythm in reverse would be ta-ti-ai, because it contains 1 16th note, followed by 3 16th notes tied together. Using this same logic, this rhythm is 1 16th note, followed by 2 tied 16th notes, followed by another single 16th note, giving us tati-yati. Putting all of this together, we would tam this example like this. Ta-yati tati tati tati-ai, tati-yati tati-yati tati-tati ta-yati tati-ai ta. While these feel slightly awkward at first, kids do get them. And we maintain the benefits of building in subdivision and only having one label for each rhythm, regardless of the meter or placement within a measure of that rhythm. Another benefit to tam counting is the consistency between simple and compound meters. When we tam in compound meters, the only thing that changes in how we count is the only thing that changes between these meters. Which beat gets the emphasis? Everything else stays the same. In the 3/4 example, we have 6 subdivisions in a measure felt in 3 groups of 2 subdivisions because of how we emphasize every other beat. Ta 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 ta. Moving this same pattern of 8th notes and rests into 6/8 times sounds different because we emphasize every 3rd note, creating 2 groups of 3. Ta 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 ta. Tamming keeps the syllables and thinking consistent, but just changes where the emphasis lands. We also have our students change their finger metronome between simple and compound meter. In simple meter, the finger metronome has 2 positions, downbeat and upbeat, ta ta, and in compound meter, it has 3 positions, ta ta ta. So, 6 8th notes in 3/4 time would sound like this. Ta 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 ta. And 6 8th notes in 6/8 time would sound like this. Ta 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 ta. Notice that I'm also changing the pitch of my voice to help students understand the difference between the 2 kinds of meters. Counting any rhythms longer than 8th notes in compound meters uses the same logic as extending notes in simple meters. Use a T articulation at the beginning of each new note and add the same number of ahs as there are subdivisions. The only difference is that we emphasize every 3 rather than every 2 subdivisions. This 6/8 example would be tammed like this. Ta 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 ta. Rhythms that include 16th notes use the same logic outlined at the beginning of this video, again emphasizing every 3rd 8th note. Ta-ya-ti-ta, ta-ta-ti-ta, ta-ti-ta-ti-ta, ta. In complex or asymmetric meters, nothing in Tam counting changes. Just like we want our students to perform, we simply shift the emphasis between every 2 and every 3/8 notes depending on the music. In this example, the pattern of 2s and 3s shifts in every measure, but tamming it is easy and yields a much more musical result than if a student simply counted to 7 3 times. Ta 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 ta. Notice how much better students would perform and how much better we can assess their understanding than if we use traditional counting. Here's the same example counted in numbers. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Or even worse, I've heard many students and even some music teachers count this as 1, 2, 3, 4, 5, 6, 7, which changes the meter to 4/4 time. A challenging rhythm like this passage is simply a combination of the concepts already outlined. Ta, 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 ti, ta, 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 ti, ta, 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 ya, ti, ta, 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 To tam cut time or other meters where a half note gets 1 beat, simply cut the count of every note in half. The quarter note becomes ta and is the subdivision basis for these meters. Ta, 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 ti, ta, 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 ti, ta, ta, ti, ta, ya, ti, ta, ti, ya, ti, ta. If you want a counting system that is easier for students to understand and provides them a tool to count more accurately and musically, Tam counting is the way to go. For more resources to help your students play better, check out buildbetterbands.com.